I'm Wang Jiangtao, coming from Zhengzhou University, China. I'm glad to communicate academic questions and ideas with you. The title of my presentation is Visual Stimulus Specific Adaptation in Midbrain Selective Attention Network. The content is listed as follows. Visual stimuli attract animals' attention by a bottom-up style. This progress is driven by silence. The silence of object not only results from stimulus competition with surrounding objects, just like this red ball against the other blue ones, but also depends on how current stimulus differ from past stimulus, such as the red ball from past blue ones. This is a broad midbrain selective attention network, in which IMC is a keynote for a special silence mapping. Previous studies used a constant order paradigm to demonstrate that optic tactium can reduce response to repeated stimulus, but recover the response to a novel stimulus, displaying visual SSA. Since optic tactium and the IMC are closely interacting, we asked whether IMC could also show SSA to motion direction. To answer this question, we use a constant order paradigm which comprises 22 blocks, and each block includes 20 motion trails at one direction, followed by a block with 20 swipes at another direction. The first presentation in each block is set as a deviant stimulus, while the last one as a common stimulus. Response to the common and deviant stimulus is indicated as SE and SD. To quantify the SSA effect for each direction, the stimulus index, which is a normalized difference between the mean response to the deviant stimulus and the mean response to the common stimulus, is introduced. If the adaptation is stimulus specific, the sum of SI1 and SI2 should be greater than 0. Here, we select the upward direction and downward direction as direction 1 and direction 2, respectively. Firstly, we want to know if this adaptation exists in IMC. Figure A shows the last plot of an example IMC neuron to repeated stimuli. Figure B shows the average response across the chart. Figure C shows the first presentation is significantly greater than the last one. So, this example IMC neuron shows adaptation to motion direction. Then we asked if that adaptation exists at the population level. Figure D to F show population adaptation to motion at different intervals. This adaptation is not dependent on a specific interval and is long-lasting up to 95 seconds later. Next, we also want to know if this adaptation is SSA. Figure A shows the response of example IMC neuron to constant order paradigm. SI for direction 1 and direction 2 is 0.17 and 0.08 respectively. So this example IMC neuron shows SSI to motion direction. And figure B shows population response to constant order paradigm. The response to first presentation of motion direction is significantly larger than most subsequent stimuli for both directions. The distribution of sum is significantly greater than 0, and 88% of our recorded neurons show visual SSA. Lastly, the SI1 is significantly greater than SI2 at the population level, showing direction dependence of visual SSA in IMC. IMC neurons show long-lasting adaptation to motion direction, and that adaptation is SSA. The upward motion shows larger degree of adaptation than the downward motion. Thank you for your attention.